Good afternoon, this is Schweitzer. We're going to run through our last little bit of ionic compounds here. We're going to do some practice questions. Again, this is designed for you to be working on a little bit and see what you got here. So, aluminum chloride, which is an ionic compound, you got a metal and a non-metal, is produced by the reaction of aluminum chlorine gas. This type of reaction is called a redox reaction or oxidation reduction. Define this. So this is a process that loses electrons. Sometimes people say Leo, the lion, says Gur. So they changed the name of these things, so it's difficult to really understand why reduction is used to describe something that's gaining. But it meant reducing oxygen and gaining oxygen. So, but they've changed it, but that the oxygen part still works. So they left that, but they added this on. So that's lose electrons, oxidize. This is gain electrons. Sorry for the sloppiness because I don't want to do it for a reduction. Okay. Write what's taking place here. Okay, so let's see what we got here. Aluminum is going from aluminum to its standard aluminum compound, or ion, which is aluminum plus 3. Now, the both sides, they got to be equal. Okay, so we know 3 electrons are involved here. Sometimes people have a hard time knowing which side to put the electrons on. But you would note that if I want to make sure they're equal. So if I put them on this side, then I have a 0 and a negative 3 is a negative 3, positive 3. I don't want that. I want them to be the same. So I'm going to put it on this side, and I get a negative 3 and a positive 3 equals 0. This is a snapshot before, this is a snapshot after. You should note that aluminum has 13, so I'm going to just add a little extra on here. This is not normally part of it, but aluminum has 13 protons here, and it's got 13 electrons. Now it's got 13 protons and 10 electrons. There's the other 3 electrons. Snapshot before, snapshot afterwards. Alright, so next one, reduction would be the chlorine then. Would be Cl2, because that's a diatomic atom, goes to Cl negative, 2 of them, and this guy's got to pick up electrons. Okay. Combine these two reactions and write a balanced half reaction. Okay, so this is something we did earlier. So I'm going to go aluminum. I'm going to rewrite it. Aluminum. Well, so I want these to equal. So I have 3 here and 2 here, so the common multiple is 6. So let's go 3 here. Sorry, 2 here. Multiply by 2. 2, 2, and 6. Okay. And then here times 3. Okay. 3 and 2 times 3 is 6. So I'm getting a ratio here of aluminums to chlorine production of 2 to 6 ratio. And that simplified in the empirical form would be just a 1 to 3 ratio, which is what we get aluminum chloride. Well, again, that's the long way of doing it. You should probably be aware that you could charge balance this thing to get the same answer. Okay? And here's the overall balance reaction would be 2 aluminums plus 3 chlorines yields. In this case, we'll bend the value you want to write 2Al plus 3s plus 6 Cl minuses. And one could write that as just 2 AlCl3s. The correct formula is Al2Cl6, and the answer is nullified because it's not empirical. Remember, this is an ionic compound that is simply a bulk crystal, so we want to make sure we understand that idea. Next page. Alright, NaCl and aluminum chloride are placed in a clay pot. A student heats the two substances in the pot and notices yellow gas emerging. When the temperature reaches approximately 900 degrees Celsius and then once again the temperature reached approximately 2500. Okay, so it's got a little typo there, we'll fix that. All right, so answer the questions. At 900 degrees, producing yellow gas, that likely, what melted? So we got in this clay pot, we have NaCl, and we have aluminum chloride. So one of them decomposed, and we want to know which one decomposed first. Okay, well, we want to get melting point. This is a plus 3 minus 1 plus 1 minus 1. So based on charges, this should have the lower melting point, and therefore that's the one that should have melted at about 900. Okay. Would magnesium, so they're saying at 900 degrees, this guy melted, and at 2500, this guy melted. Oof, quite a bit higher. Much larger Coulomb attractions. Would magnesium chloride be higher or lower than 900? Well, you can see here that this is 3500, be someplace between. The plus 2 charge and the minus 1, plus 1 minus 1, plus 3 minus 1. This is the one to be right in the middle of those two, so it would be higher than this guy. A student checks back and the container is at 3000 and it's at 3000 degrees and the container is still solid. The pot is made of an ionic compound with a large charges causing a higher melting point. Student B, the substance is an ionic substance because simply made of a substance that just always solid and therefore that there's no consequence. This is something that I guess I don't know if I would know enough. It says justify or nullify all or parts. This pot's made of an ionic compound. I don't know for sure. We don't know what the pot's made out of. Oh, okay, never mind. Here it's silicon oxide. Okay, is that an ionic compound? No, it's two nonmetals. A nonmetal bound to a nonmetal. This is not ionic. Okay, a large ionic charges. No, again, this whole thing is wrong. Okay. B, substance is not ionic substance, so that's true. All right. It's made of a substance that is always solid, and therefore the temperature is of no consequence. This is, nothing is always solid. You start heating it up, the molecules will start shifting back and forth and breaking the bond between them, and eventually it will melt. This is a substance that has a very, very, very strong bond. And I believe that comes down to the end here. I don't know. Thank you very much.